Hi guys, we're back and we're going to do a little review today. And this is what we're going to review. IAT. So this can be really confusing, and this is the indirect antiglobulin. Antiglobulin test. Okay. And how we're going to describe this today, this really is a method. Okay. This is a method. And we're going to use this method for multiple tests in blood bank. Okay. So this is a method, and we're going to use it for several tests. First off, we will use it for a week D, slightly modified with the week D. We will use it for an antibody screening test. So your antibody screen, we will use it for. We'll use it for a full cross match. Okay. There are different cross matches that we'll use it for. What goes along with an antibody screening is if we find an antibody, we'll do an antibody panel. We'll use it for that. And occasionally, we're going to use it for antigen typing as well. So it is a method that can be used for multiple tests. Okay. So let's start. We're going to apply this right now to an antibody screen, and just to see what's going on inside the tubes. So we're going to start off with our tubes right here. Oh, we don't want a square. Let's get rid of that. We'll go back with the oval. We'll make one tube, and we're just going to do an antibody screening with 2 screening cells. Some places may use 3, but for our example right now, we're going to use 2. Okay, so this will be screening cell 1, and this will be screening cell 2. Okay. We're going to have different phases of this test occurring, and we'll record our results down here. So for cell 1 and 2, we're going to have immediate spin phase. We'll have a 37-degree phase, and we'll have our AHG, which is anti-human globulin phase. And then we're going to put a spot here for our Coombs control cells or our check cells. Okay, and we're going to have a little chart for that, and we'll record our results, and then we'll have an interpretation at the end as well. Okay, so let's go ahead, we'll get this ready, and now let's talk about what's going on inside these cells. Okay, so what are we going to add to them? Well, first off, what we're going to add, and we'll draw these, we're going to add our screening cells. Okay, so you see them in here. There's one screening cell. We'll put a few in here. You're going to add 1 drop of screening cells into your tubes. And then we'll look and we'll determine what our screening cells are about. Okay, so there's 1 drop of our screening cells. Now what we're also going to add is, here's our patient plasma. And I'll draw that like a drop. Okay, so we have our patient plasma here, and we want to put a drop of patient plasma, actually 2 drops of patient plasma into tube 1 and 2 drops into tube 2. And so that we see this, I'm going to go ahead and I'm going to make 2 drops here so that you see 2 of them. So we put 2 drops of plasma in there. And one thing I want to talk about too is what's in this drop of plasma, what's in patient plasma. Okay, and what are we looking for in this screen, right? So we have screening cell 1, screening cell 2, 2 drops of the patient plasma, and our drop of plasma here, we actually know there's a lot of things in it. We have electrolytes in there, so there's sodium, chloride, potassium, a lot more. Sorry, let me fix that chloride. Okay, negative. We have antibodies in here to other things. And most of my videos, when I make these, when I designate some other antibodies, specifically I like to use chickenpox. Okay, it has a beak on it. So this is my chickenpox antibody, and if this patient had chickenpox, they have the chickenpox antibody in here, and they have lots of them. Okay, so they have that immune response in case they contact it again. We're going to have glucose in here for our cells. Just think about any chemistry panel that you run. Sodium, potassium, chloride, bicarbonate, glucose, BUN, creatinine. You're also going to have hormones, TSH. We can write TSH on here. We'll designate that. Let's make it a triangle. So that's in there, different hormones. So there's a lot of different proteins incorporated in here. And what we're specifically looking for is an antibody, let's make it this color, that's directed against someone else's red blood cell. Okay, so if this patient's been transfused or pregnant in the past, transfused or pregnant, they've been exposed to someone else's blood. And when you're exposed to someone else's blood and it's different than yours, you can make antibodies to it. Okay? So that's what we're looking for in this antibody screen. Has this patient been exposed to someone else's blood in the past, and have they made an antibody to it? And when we look at this, I want you to look at these right here. This is an anagram, okay? And this is a map. Okay, this is a map. I want to do reds, and these are our screening cells. Okay, so it's a map of their antigens that are on the outside of these red blood cells. So if we look at this, we're going to see that screening cell 1 right here. That's a little big. I want to make that a little smaller here. Okay, so number 1 here. This is the map of antigens that are on the outside of this red blood cell. So if we look at screening cell 1, oops, I'm clicking on the wrong buttons here, I apologize. Here's screening cell 1, we'll just put a 1 inside there, okay? What's on the outside of it? Well, as we look at this, we're going to see these pluses right here. And that means this screening cell 1 has D antigen on the outside of it. And it also has C antigen on the outside of it. So we'll draw a couple of those. These zeros right here, this means they don't have the little c or the big E on the outside of those red blood cells. Okay? And this plus right here means this one has a little E on it. It does not have CW, it doesn't have Cal, so those aren't on this one. Okay. As we go across, it has little k. Okay, so we can put a little k on it. That's hard to tell that that's little. Okay. KPB, JSB, Duffy A. So these are all what is on the exterior, the membrane of that screening cell 1. And 2, on the other hand, so if we look at screening cell 2, let's draw a picture of it. There's 2. As we look at this one, and I'll highlight it just a different color right here. This is screening cell 2. Remember, we just got to look at it as a map. This one also has D on it. Okay, so the D is the same as 1, but it doesn't have big C. Okay, so that one's not on there. But on the contrary, it has little c and E. So we can put little c on here and little e. Or big E, I'm sorry. Big E. Has big E. So we'll draw that membrane again and we'll put a big E on there. Okay. screening cell 1 had little e. This one has big E. And so as we go across here, we can see what it's positive for. Okay, so this is important to understand. And because those are positive on there, if the patient has an antibody, let's draw an antibody here. Remember how we designate them. And these are specifically, we're looking for IgG ones at the moment in this testing. Okay, so if this patient has an antibody to, let's say, big C, okay, let me erase this, big C. Let's think about big C at the moment. So we'll put a big C on the top of this. Okay. So if this patient that we're testing at the moment has that antibody, and we mix it with these cells, okay, their plasma, we'll go back, we'll put this in a drop of plasma. Oh, that was supposed to go orange. I wanted it orange. We're going to mix it with this cell and mix it with this cell. So that antibody in big C, it will bind right here because it's a big C. All right. This one, on the contrary, number 2, there's no big C on the outside of this cell. So this big C antibody doesn't have anything to attach to. Okay, so let's think about that as we proceed with this test. Okay, so let's go back up here. So we add the plasma, and when we add this plasma, and we'll go ahead and let's say this is going to be, we're not going to distinguish it yet. So we'll just say, here's a red cell antibody. Okay, let me go ahead. I can put that back in there. Okay, but when we add that plasma, we're also adding those chickenpox antibodies. Maybe you had the flu vaccine. So some flu vaccine antibodies. We know they don't last forever. That's all right. Okay, so if there's a red cell antibody, and we'll just show it's attaching to this one. Okay, because there's something on the outside of screening cell 1 that it matches to. So we centrifuge these, so an immediate spin. This is 15 to 20 seconds. We spin this, okay, and we read the tubes. Okay, and according to my picture up here, this is immediate spin. These are an IgG antibody. Okay, so since it's an IgG antibody, immediate spin is room temperature. We are likely not going to see a reaction. So we will not see any agglutination in that tube because IgG antibodies, okay, for one, they're small, and so they cannot make that lattice. Okay? Remember, we like to see this lattice. And those IgM antibodies are so good at it because, okay, they have 10 sites. 10 antigen binding sites, so they can form that lattice network. So an IgM antibody we can see at room temperature at immediate spin because they form that lattice of agglutination, where this IgG cannot do that. All right, so next what we're going to do is we are going to add enhancement media. And let's go ahead and we'll make that a different color. We'll make it blue. Okay. So we'll add 2 drops of enhancement media. And this can be anything like, okay, we'll call it LIS, which is low ionic strength solution. Okay. It could be PEG. It's another one. Or albumin is also another one. And again, we add 2 drops. Why do we add 2 drops? Because we had 2 drops of plasma. Okay, so we add the 2 drops of that in there. So it's now floating around in there. Okay, it's in here. We'll just draw a little. And what this low ionic strength solution does is it allows those red blood cells to get closer together so that we can have the cross-linking of some of these antibodies to see agglutination. When we add the enhancement media, okay, we're going to put it in the incubator, okay, at 37 degrees. And this can be anywhere from maybe 15 minutes to 30 minutes. But it decreases the time, because without enhancement media, we would have to incubate it for at least 60 minutes. Okay? And the emergency room, if you're sitting in the emergency room, you don't, that's too long. Okay? So now we're going to incubate it. And after incubation, we're going to centrifuge it again, 15 to 20 seconds, and read it. And once again, I'm going to throw this out there and warn you. Most of the time, if it's an IgG antibody, you're not going to see a reaction at 37 degrees. Again, they're just not strong enough. They can't form that lattice over here like our IgM does to see that reaction. But the antibodies sensitized those cells, okay? But we can't see it. So how are we going to see it? What do we do next? So what we do at this point, and let's clean up our image here a little bit for you guys. Okay, so we have some space. Okay, now we're going to add our AHG, and it usually is green. And what is our AHG? So our AHG is anti-IgG, or, and it can be poly, okay, it's going to be poly, or if it's poly, it's also going to have C3D in it. So this is our complement and our IgG. And what, yes, what we want to establish here, that this is an antibody that has been made and manufactured to an antibody. Okay. This is an antibody against a human, specifically human, IgG antibody. Okay, so it's an antibody to human IgG. Now, it doesn't distinguish between different antibodies, IgG antibodies. Say, for instance, if we had over here, I'll just put it right below it, if we had our chickenpox antibody, and we wanted to draw that here, here's our chickenpox, and let's make this our red cell antibody that we're trying to find. When we add this AHG to it, it is just going to bind to anything that is an IgG antibody. So it's going to bind to both of these indiscriminately. Okay? It does not distinguish between chickenpox antibodies, red blood cell antibodies, our Epstein-Barr virus antibodies, that's mono. Okay? It doesn't distinguish between our flu shot antibodies. It will bind to all of these because that's what it's made to do, just bind to human antibodies. So before we can add this anti-IgG, what we have to do is wash. And what that washing does, so we're going to fill these tubes with saline. Okay? We're going to fill them up with saline. All right. We're going to centrifuge them for 60 seconds. Okay. And in that 60 seconds, this is way longer than our 15 to 20 that we're typically doing. We are compacting these red blood cells to the very bottom of this tube. Okay, we are smushing them on here, okay, so that they stay. Because once we fill it with saline, we centrifuge it for 60 seconds, we're going to dump that saline out. And those red cells are going to stay on the bottom of this tube. Before we add more saline, we want to resuspend them, add more saline to wash them. And as we're washing them, what I want you to see here, and I tried to do this, as we're washing them, we are getting rid of all of these extra things floating around the red blood cells. Okay, we're washing that all away. But what we're not washing away are the red cells, and we're also not washing away the antibodies that are attached to these red cells in this tube. They're staying because they've attached. So what happens when we finish our wash, so we wash it 3 times, times 3. Okay. After that wash of 3 times, let's get some space here so we can see. Okay. We're going to add our AHG. Our AHG, we're going to have 2 drops, because we had 2 drops of plasma. They're going to take these 2 drops, add that into here, and into here. And so what's in our AHG? Anti-IgG. This is an anti-IgG. So when we add that, they're now going to bind and pull these guys together. But over here, they're just going to float around. Okay. So when we centrifuge this, what's going to occur in tube number 1, because those have bound, okay, we have those multiple red blood cells in there, okay, that had this antibody on it. And it had multiple ones. Okay. It's not specific that only one occurs. There's usually more than one. Then when we add this, because it's an antibody to that, we're now binding all of these guys together, and we are creating much weaker than the IgG, but we are now creating that lattice formation so we can see agglutination. So in this tube here, number 1, we're going to see weak agglutination, probably about a 2+. And in tube number 2, because there was no antibodies to that anti-IgG to bind to, we're not going to see anything. Okay. What we have to do now that we have a negative reaction, we have to verify our with our check cells that we performed the test properly. Okay. So now what we're going to do is we're going to add Coombs control cells. What are Coombs control cells? So Coombs control cells, let's get another clean slate here so we can see what's going on in there. Okay. We're going to call these our check cells. Okay. What are they? So these check cells have antibodies all over them. Okay. So they are sensitized with antibodies. You see that? So when we add these guys now into here, and remember they only go into our negative tubes, okay? But when we add them into there, now we're going to have these check cells. Let me make them a different red color. They really need to be a little different for us to see it. Let's see. That's not dark. Well, we'll see if we'll make them pink. Okay. So these are our check cells. Not a significant difference in color, but that's all right. So they have the antibodies on them, right? All over them. And so what happens now is our AHG that's in there binds to them. And we will see agglutination. So now, once we've added our check cells, we should see a 1 to 2 plus reaction. Okay, so we'll put a 2 plus in here, which means we did our test properly. We can just put a line in here because we didn't do it because it was positive. We didn't add it to there. And now when we interpret our antibody screen, we had 1 positive cell and 1 negative cell, but as a whole, we're going to result the screen as positive. So that's a positive antibody screen. Okay, so we have now determined that we have a positive antibody screen. So what's our next step? Or what exactly does this mean? So our positive antibody screen is just it's a screening test. If you remember, we talked about like HIV screening tests and so forth, a strep screen test previously. So we're just screening to get a positive or negative. And now we have to take the next step, okay? We have to take the next step to actually identify. Okay? We want to identify what's causing this positive reaction here. Okay? What is it? And when we talk about HIV or strep, we do a confirmatory test that's actually more specific to those infectious agents. Okay, so now what we do here is we're going to do a confirmatory test to identify what the antibody actually is, and we're going to do an antibody panel. Okay, an antibody panel, or what you might hear someone say is an antibody ID. Okay, because we want to identify it. And so this is where we take that panel now that has typically 1 to 12, maybe 11, okay, and the reason why it would be 11 cells, okay, and that's usually because number 12 is going to be your auto control, and we'll talk a little bit more about that one later. And then that balances your centrifuge. So we do like to keep things pretty convenient so that it works well for us. So that's our next step, an antibody panel, and we'll move on to that in another video. And I'm also going to put together a short video and talk about specifically our check cells and why they might be negative and what to do at that point. All right, guys, it's been great. Signing off.